Have you ever spent days, maybe even weeks, building the perfect dashboard, only for someone to tell you the data is wrong? Ugh, if that sounds familiar, then you're in the right place. Today, we're diving into data quality, what it is, why it so often breaks, and how you can start building data systems that people can actually trust. Oh yeah, we've all been there. You get back to your desk and you see this little yellow sticky note. It's a total gut punch, right? It's a tiny piece of paper that points to this huge, expensive problem that can undermine your entire data strategy. And believe it or not, this single frustrating moment is exactly where our story begins.
This problem actually has a name. It's called data downtime. And honestly, you can think of it just like application downtime. When a website is down, customers can't use it. Simple as that. Well, when your data is down, meaning it's wrong, it's incomplete, or it's just plain old, your team can't use it to make decisions. And that can cost a company millions.
So, just how big is this data is wrong problem, really? Well, it's not just about a few numbers being off here and there. It's a systemic issue that wastes a ton of time and resources. And the real cost? It might actually shock you. 40%. Just let that sink in for a second. Studies are showing that data teams spend up to 40% of their time just firefighting. Validating reports, hunting down errors, fixing broken data pipelines. That's 2 full days out of every single work week spent on reactive work instead of driving the business forward. This isn't just an accuracy problem, it's a massive productivity killer. So you have to wonder, why does it feel like this problem is getting worse, not better? Well, as it turns out, this is a very modern crisis. It's being driven by a few key trends in how we all manage data today. So let's break down what's really going on. Okay, first up, the cloud. Tools like Snowflake and BigQuery have given us absolutely incredible speed and power. I mean, it's amazing. But here's the catch. All that access and all that speed has created a huge surge in complexity, which has made our data systems more fragile than ever before. Second, we're dealing with an absolute explosion of data sources. A typical company today is pulling data from dozens, sometimes hundreds of different places. Now, if any one of those sources decides to change its format without telling you, boom, your entire pipeline breaks. Every new source is like another potential landmine you have to navigate. And third, our data pipelines themselves have become this incredibly complex, tangled web. Data doesn't just move in a nice straight line anymore. It flows through all these different tools and systems. And that creates these really fragile dependencies where one tiny change over here can set off a disastrous chain reaction all the way downstream. And finally, our teams have changed too. Data isn't just managed by some small central group anymore. Now we have specialists all over the business, data scientists, analytics engineers, BI analysts, and they're all touching the data. And while that's great for getting expertise closer to the business problems, it also means miscommunication and uncoordinated changes are pretty much inevitable. So what we have is this perfect storm of speed, complexity, and decentralization. And the old ways of managing data, they're just not cutting it anymore. But the good news is, we've kind of seen this movie before in the software engineering world. The solution is really a cultural shift, borrowing from a playbook that we know works. It's about moving from a DevOps mindset to a data ops mindset. So, what is data ops, really? Well, at its core, it's about treating your data with the exact same discipline that you treat your code. It's about applying principles like automation, monitoring, and continuous integration to make your data pipelines more reliable and performant. Really, it's a huge shift from being reactive to being proactive. But, to really do data ops right, you need the right architecture underneath it all. So how exactly are modern teams organizing this massive flood of data they handle every single day? It all starts with 2 key concepts. Okay, let's talk about the 2 big ones, the data warehouse and the data lake. A data warehouse is like a neatly organized library. It stores structured, cleaned up data that's all ready to go for business analytics. A data lake, on the other hand, think of it like a vast natural lake. You can pour basically anything into it, raw, unstructured data of any kind, which gives data scientists incredible flexibility to explore. And here's how they often play together. You see on the left, you've got raw data from all sorts of places, sensors, logs, APIs, and it flows into a data lake. From there, it gets pulled through an integration layer that cleans it all up and gives it structure, before loading it into a data warehouse, where it's polished and ready for analysis. Now, an even more cutting-edge idea you're hearing about is the data mesh. Instead of having one central team manage absolutely everything, this approach decentralizes ownership. So think of it this way.
The marketing team owns its data as a product. They are responsible for delivering clean, reliable marketing data to the rest of the company, and everyone's playing by a shared set of rules. Look, whether you have a simple pipeline or a super complex data mesh, none of it matters if people can't trust the data. And trust doesn't just come from wishful thinking, it comes from measurement. So, how do we actually start measuring the health of our data? So, where does that trust really begin? It's not about just crossing your fingers and hoping for the best. It's about asking the right questions over and over and doing it automatically. And these are really the 5 foundational questions you need to ask. First, you've got the freshness check. Is our data actually up to date? Second, completeness. Are there rows missing that shouldn't be? Then, you look at the values themselves. Are the numbers within a normal range? And how many of them are just nulls? And finally, you have to check the schema. Has the underlying structure changed on us without warning? Answering these 5 questions automatically, that's the critical first step to building data you can truly rely on. And that brings us to our final thought for today. It's so easy to just glance at a dashboard and assume everything's fine because the chart looks right. But the real question, the one that keeps the best data leaders up at night, is this. Can you really, truly trust the data that's hiding behind the numbers?